Okay, simultaneous equations. This is chapter 12b. We covered in class yesterday. I just want to go over it in a little bit more detail so that you can get to have a look at how it all works, and you can have a go at exercise 12b at completing that exercise. So we've got a set of simultaneous equations. 4x plus 2y equals 5, 3x plus 2y equals 2. You've learnt other techniques to be able to solve those simultaneous equations. We're going to do it with matrices right now. Basically what we do when we've got simultaneous equations, this is a straight line on a graph, this is a straight line on a graph. We're finding the point where the two straight lines cross. And that's exactly what we're doing when we're solving simultaneous equations. Just finding that point where the two equations cross. So we're going to set up a matrix just using the coefficients of the x and y. So our matrix is going to be 4, 2, 3 and 2, and that's going to be our A matrix. Then we have our x matrix, so this is our A matrix. Then we have our x matrix, which is just a 2 by 1 matrix with an x and a y in it. And that's going to equal another 2 by 1 matrix, because a 2 by 2 by 2 by 1 equals a 2 by 1, and that's going to equal 5, 2. So that's A times x equals C. So if we're going to expand out the matrix, we get this row with the column, 4x plus 2y, that's what we've got up there. This row with the column, 3x plus 2y, 3x plus 2y. Okay, so that's all we've done. Now, what we need to do is we need to get the x on its own, and we do that with its inverse or opposite operation. Okay, so what we want to do is we want to multiply the front of this equation by a to the power of minus 1. So if we go a to the power of minus 1 times ax, and if we do what we do to one side we have to do to the other, so we've got a to the power of minus 1 times c, then what ends up happening is that's the identity matrix, 1, 0, 0, 1 times x, and it equals a to the minus 1c. And whenever we multiply it by something by the identity matrix, we just get that matrix, so that disappears. And our solution is just going to be a to the power of minus 1c. So we can see all of that just summarised up there. The key point here is that x equals a to the minus 1c. That is going to be our key result. That's what needs to be in your bound of reference. All the time, whenever we're solving simultaneous equations, x is equal to a to the minus 1c. Now the order is important. Because we have to multiply the a to the power of minus 1 out the front here, we can't put it between the a and the x, it has to be at the front. It has to be at the front of the c. Okay, so it's a to the power of minus 1 times c. If you get them the other way around, you'll get a different result. So we're going to do these mainly on your CAS calculator, but if we're going to multiply them out, we're going to multiply, so a to the power of minus 1c would look like that. We'd do this row with the column, 1 times 5 plus negative 1 times 2 gives us 3. 5 minus 2 is 3. This row with the column, negative 1.5 times 5 plus 2 times 2, negative 7.5 plus 4 is negative 3.5. And so what that actually means, that's going to be equal to our xy matrix. So that means x equals 3 and y equals negative 3.5. And we could substitute them into the equations and we'll get the correct answers. So that's solving, that's a really quick summary of solving simultaneous equations. That's always going to be, even if it's a 3 by 3 or a 4 by 4 matrix, we're going to do x is going to equal a to the power of minus 1 times c. On your CAS, you're going to define that matrix as matrix A, you're going to define that matrix at matrix C, and all you need to do in your CAS is type in a to the power of minus 1c on your CAS, a to the power of minus 1 times c on your cas, and it will just give you this matrix, and that's your xy matrix. If you need to copy this down, you do need to have this in your bound reference. Just pause the video to get it, otherwise we'll go on. Now, there are a couple of anomalies. The first one are what we call inconsistent equations. So I've got these two equations. Our A matrix is going to be, there's 1x there, so it's going to be 1, 2, 2, and 4. And if we go and work out the determinant of A is AB minus AC minus BD, so it's going to be 1 times 4 minus 2 times 2, which is 4 minus 4, which is 0. Now remember, we need to get a to the power of minus 1. So a to the power of minus 1 is 1 over the determinant, which is 0. We can't do divided by 0. The rest of it would be, we swap these two numbers around, 1 and 4, so we've got 4 and 1, negative 2, negative 2. But we can't do divided by 0. So there's no result. Or an error. And why that happens, if we have a look, if we plotted these two lines on a graph, this is what they would look like. So they've both got a gradient. They're going, if the gradient is minus 0.5 for each of them, it's the same gradient. So that means they are parallel lines. Parallel lines never cross. So in this case, when the determinant is 0, there is no solution. And that's why we get an error. Okay, so if the determinant is A, and if the determinant is 0, there is no solution, and one of those reasons might be because the equations are inconsistent or they are parallel. Okay. And we'll go on to the next page. Once again, you can pause if you need to copy that. You probably don't need to have that copied, you just need to understand this video. We've got some notes yesterday. The other situation is if we have a dependent equations. Okay, so if we have a look at that equation there, and we take that equation and we divide everything by 2, we end up with x plus 2y equals 4. If we have a look at that, that equation is the same as that equation up there. Effectively, these two are the same equations, so there's the same line on the graph, so they meet at every point. Once again, this one, A equals 1, 2, 2, 4. The determinant of A is going to be 4 minus 4, which is 0. So once again, the determinant is 0, and the reason that doesn't work is because they are the same equation. Okay, so they meet at every single point. There are an infinite number of points where they meet. Okay, so we've got two situations. We've got inconsistent equations when the determinant is 0, if they're parallel lines, or if they're the same line, just written differently. They're called dependent equations, and once again the determinant is 0, and we can't get a solution. So if we get a determinant of 0, there are no solutions, and it will be for one of those reasons. Okay, so let's look at example 4. Example 4 is on page 424 of your book, and we're going to do this using your CAS. Okay, so this is a CAS question. We set up our A matrix, 3, 4, 2, 3, 3, 4, 2, 3. The numbers there just go straight down. We set up our C matrix, which is just 6, 4. And on the CAS, to solve for x, we get A to the minus 1 C, and that will equal 2, 0. If you do that on your CAS. So pause the video, put these into your CAS and have a go. Define that as A, define that as C, work out A to the minus 1 C, you should get 2, 0, and that means that's your xy matrix, x equals 2 and y equals 0. We put them into the equation. 3 times 2 is 6, plus 4 times nothing is nothing, which is 6. 2 times 2 is 4, plus 3 times nothing is nothing, which is 4, and we know we've got the right answer. One more example, and this one's a 3 by 3 matrix. Okay, you're only going to do these. You couldn't. These will be a bit difficult to do by hand. You don't know how to work out the determinant of a 3 by 3 matrix, so we're going to let your CAS do it. So once again, it's a CAS question. So pause the video, define A in your CAS, define C in your CAS, and let's have a go and see if you can get this answer. Now, the reason A is like this, just note this one only has an X and a Y term. This has got an X, a Y, a Z. This one's only got an X and a Y. This one's got an X, a Y, and a Z. So we go 3, 4, and -2 because it's a minus there. 3, 4, and -2. 2 for X, 3 for Y, and nothing for Z. So we put a 0 in there. And 1 for X, 2 for Y, 3 for Z. Okay, that's going to be multiplied by your it's going to be multiplied by the X, Y, Z matrix, and that will equal C. When we work out in your CAS A to the minus 1C, we should get this matrix, X, Y, and Z. So X is 11, Y is -7, and Z is 0. Okay, and we could go and check that. 2 times -11 is -22, plus 3 times -7. What's that? Anyway, it will work. Okay, so we can substitute in there, and there are our solutions. Okay, so that was example 6, and that's on page 426 of your book. There is also an example 7, a practical application. So have a look at example 7, and then have a look at example 7 on page 427, and then do exercise 12B in the textbook. Okay, try and have everything up to date by the start of Friday or the end of Thursday, and on Friday we'll be looking at exercise 12C1. Okay, thank you.